Hello, let's solve Mathematics Paper 2, 2025, last year's grade 12 exam. We are going to solve question 1. Now, the question reads, given that matrix L is equal to negative 2, and 6, then 7 being the elements in this matrix, and matrix M is equal to x, -3, and -4, and a +2. Now we are told to find the value of x for which determinant of matrices L and M are equal. So the first step that we are going to do for us to find the value of x, we are going to find the determinant of matrix L. We are going to find the determinant of matrix L. So the first step is to find det of matrix L. So the determinant of matrix L is going to be equal to, so we are going to say the det of matrix L. Remember, the formula is the product of the major diagonal minus the product of the minor diagonal. So according to the major diagonal elements, we have a -2 and a 7. So we are going to say product simply means we are trying to multiply. This is a -2 times 7. Then we put them in brackets minus the product of the minor diagonal, which is 6 times -2. So this one is going to be a 6 times -2. So now the determinant of matrix L is going to be equal to -2 times 7. We are getting a -14. So this is going to be -14. Then 6 times -2, we are going to get a -12. So this is going to give us -12. Remember, we are finding first the determinant of matrix what? Matrix L, so that we can equate it to matrix M. Then this negative times negative is going to give us a positive. So this is going to be a -14 plus 12. -14 plus 12. The determinant of matrix L is going to be a -2. Now, this is just the first step of our procedure leading us to find the value of x. So now that we have the determinant of matrix L, we are going to say, therefore, det of what? Matrix M is going to be equal to, remember, it is 2 times x. We are going to say 2 times x. We put them in brackets minus a -3 times -4. So this is a -3, -3 times -4, -3 times -4. Yes, this is -3 times -4. Then now that they said the determinant of matrix L is equal to the determinant of matrix M. Therefore, before we can even equate it, we are going to first try to find the product here. We are going to say 2 times x. So this is just the det procedure of matrix M. 2 times x, it will give us 2x. -3 times -4, this is going to be a +12. So this will be a -12. Now, remember that the determinant of matrix L is equal to the determinant of matrix M. Therefore, the determinant of matrix L will be equated to the determinant of matrix M. So where there is det of M, we are going to put a -2, which is going to be equal to 2x minus a 12. Therefore, remember that a -12 can cross the equal sign. So this will be a -2 plus 12. This is going to be equal to 2x. Now, -2 plus 12, we are going to get a +10. A +10 is equal to 2x. Remember that we are finding the value of x. This is over 2. This is going to be over 2. These 2 and these 2 will cancel. And the value of x definitely is going to be a +5. So now, the value of x, according to the question which is presented here, is going to be a +5. Remember, the first step is to find the determinant of matrix L. Then after you find the determinant of matrix L, you are going to equate it to the procedure leading to the finding of x on matrix M. This is how we need to do it. Therefore, after we respond to this particular question, we are given Roman numeral 2, which is saying find the inverse of matrix L. Find the inverse of matrix L. Remember, when finding the inverse of matrix L, we are going to interchange the elements or numbers in the major diagonal, then we are going to multiply a negative sign to the elements or members or numbers in the minor diagonal. Remember, this is a very simple procedure. So now, let's go and solve for Roman numeral 2. So we are saying inverse of matrix L is going to be equal to 1 over det of what? Matrix L, which is matrix L is just a negative 2, and this is positive 6, and this is a negative 2, and we have a 7 here. So now we are looking for the inverse of matrix L. Remember that the inverse of matrix L is going to be equal to 1 over determinant. Determinant of matrix L, it gave us a what? A negative what? A negative 2. So this is going to be equated to, and remember that we are going to interchange the numbers in the major diagonal. So this is going to be a 7, and this will be a negative 2. And elements or numbers in the minor diagonal will be affected by a negative. Negative will be multiplied throughout the elements. Negative times 6 is going to be a negative 6. Negative times negative 2, this becomes a positive 2. Now that some other teachers recommends to end here, others would say multiply the det throughout the elements. So this can be a 7 over a negative 2, and this will be multiplied. This is going to give us a negative 1, and this will be multiplied, will give us a positive 3. 1 over 2 times a negative 2 will give us a positive 1. This is going to be the final answer of the inverse matrix of L.